Here we can see the sum of n formula, which we've used in many examples. Sn is a times 1 minus r to the n divided by 1 minus r. What we're going to discuss is the concept of summing a series to infinity. If we consider this sequence, where we can see that r is equal to 3, if we evaluate the expression here with r equals 3, the r to the n will become infinite as n becomes infinite. For large values of n, 3 to the n will be a very, very large number. This is different to the situation with the other sequence that we can see at the bottom here. Here, r is equal to a half. Each term is produced by multiplying the previous one by a half. We'll get a very different result if we look at this sequence in this expression. As n tends to infinity, r to the n will tend to 0. In this situation we can sum to infinity, and this diagram explains how. Suppose you are standing at one edge of this room. The distance between the two walls is d. You're standing here and you're told to walk halfway to the other wall, then half of the remaining distance, and half of the remaining distance, and so on. You will never reach the wall, and so the other wall, d meters away, would be the limit of the sum of the distances that you walk. And the same sort of thing applies when you're dealing with a value of r, which is between -1 and 1. So in considering the diagram, we can see that the sequence of distances that we walk towards the opposite wall gets smaller and smaller. And if we consider a geometric sequence, the terms will get smaller and smaller if r is in the range -1 to 1. Another way of saying this is that for r in this range, r to the n will tend to 0, i.e. get very small, as n tends to infinity, in other words, as n gets very large. If we now consider the Sn formula again, a times 1 minus r to the n over 1 minus r, for a large value of n, r to the n will approximate to 0, so the bracket will become 1, and the top of this expression will just become a. So a over 1 minus r is the expression for the sum to infinity of a series for which r is between -1 and 1.